The purpose of this experiment was for the speed of light to be measured using laser and different firmness of gelatin. A red laser was passed through three mediums with different amounts of gelatin. The angle of incidence, angle of refraction, and index of refraction were determined. The first step of the experiment was to obtain three containers and fill them up with 2 cups of water each. The gelatin packets were added to each one. The first container contained 2 cups of water and 2 packets of gelatin. The second container contained 2 cups of water and 4 packets of gelatin. Finally, the third container contained 2 cups of water and 6 packets of gelatin. The containers were numbered and set aside to get firmed. After the gelatin sat in the water for a while, laser pointing was tested to see which of the three containers the red laser would completely go through. The laser went through the container that contained 4 packets of gelatin, but it cut off at some point. However, the laser didn't pass through the container that contained 6 packets of gelatin. Finally, the laser went through the least dense container all the way, which was container number 1, the one with the 2 packets of gelatin. The angle of incidence was set at an angle of 45 degrees for all containers. The container that contained 2 packs of gelatin had an angle of refraction of 100, 2.22 refractive index, and 140, 3.11 refractive index. Two different types of incisions were made for the container, a triangular incision and a square-like incision. The angles of refraction were 20.44 refractive index and 40.89 refractive index. The container that contained 4 packs of gelatin, a triangular incision was made, and the angle of refraction was determined to be 130, 2.89 refractive index. The container that contained 6 packs of gelatin did not allow the laser to cut through, so an angle of refraction could not be determined. Using the angle of refraction and angle of incidence, the refractive index was calculated using the equation N2 equals sin theta 2 over sin theta 1, where theta 1 is the angle of incidence and theta 2 is the angle of refraction.